Hey guys, welcome to my channel. In this video I'll be showing you how you can perform word segmentation like this using simple image processing. So let's begin. So first we'll import these three libraries, OpenCV, NumPy and Matplotlib. Then we'll read our image, cv2.imread. Name of the image is word segmentation. .jpg. Now we'll convert it into an RGB image. img cv2.color bgr2 RGB. Now we'll get the height, width and number of channels of the image. Now if our image has a width greater than 1000 pixels, then we'll reduce it to 1000. Reducing the size of the image is helpful in reducing the time complexity of performing operations. So we'll write if width is greater than 1000, then new width is equal to 1000. Aspect ratio will be width upon height, and new height integer of new width upon aspect ratio. Now we'll resize the image. So img is equal to cv2.resize img comma new width comma new height interpolation is equal to cv2.interarea. So as per OpenCV documentation, we need to use interarea interpolation while shrinking the size of the image. So now let's display the image plt.imshow img so this is our image. So now the next thing that we'll do is we'll define a function that will get us the threshold of the image. So this is a function that we'll be using. So here first we'll convert the image to a grayscale image. Then we'll apply thresholding, wherein all the values below 80 will turn into black and remaining values will become to 55. And we are taking inverse binary of the image since the foreground is darker in color, right? The handwriting is darker in color and the page is white in color. Hence we are taking inverse of the binary operation. So we'll write thresh img is equal to, we'll pass our image, so we have got a binary image. So the first thing that we'll do is we'll try to detect the individual lines before segmenting the words. So for that first we'll have to perform dilation operation. So for that we'll first define a kernel. So kernel is equal to np.once. Let the size of the kernel be 3,85. You can change the size of the kernel according to your image. And type would be np.unsigned 8-bit integer. So dilated image is equal to cv2.dilate thresh img kernel iterations would be equal to 1. plt.imshow dilated cmap equals to gray. So here in this operation we have first defined a kernel of size 3,85, and during dilation operation the kernel cycles through the entire image, right? And if beneath the window if there is even one value which is greater than 0, then entire region within that window will become white. So this is how the kernel operation works. So here if you see, we have defined a rectangular kernel which has a lesser height and more width because we wanted to detect line, right? Hence we kept the first value as small and the second value a bit larger. Now the next thing that we'll do is we'll find the contours. So contours, comma, hierarchy is equal to cv2 dot find contours dilated dot copy cv2 dot retr external cv2 dot chain approx none. Here we are trying to detect only the external contours, right? Because there are no contours within the contours, and we need to consider all the points. Now next we'll try to find the coordinates of the contours so that we can draw a rectangle on the lines. But additionally what we'll be doing is we'll also try to sort the contours from top to bottom. So we'll add sorted contours lines contours key is equal to lambda cv2 dot bounding rect ctr. So the bounding rect actually gives a tuple, okay, which contains x location, y location, width and height, and we want to sort the lines from top to bottom, right? Hence we mention the second index, which is this. Now we'll draw the lines on the image. So before that we'll make a copy of our original image so that we can reuse it later. img2 is a copy of this original image. Now we'll use a for loop for drawing each and every contour. So for ctr in sorted contour lines x comma y comma w comma h is equal to cv2 dot bounding rect ctr cv2 dot rectangle. We'll use rectangle method for drawing the rectangle. First parameter will be the image on which we want to draw. Second would be the x and y coordinate. Next we'll write the other set of coordinates x plus w, y plus h. Next we'll define the colors. So you can use any color over here. Here I'll use 40, 100, 250. Last parameter is the thickness of the rectangle. Next we'll use plt dot enshow img2. Yep, so you can see we have successfully identified all the lines. Now that we have contoured the line and have also sorted them, we'll move on to find the contours of the individual chords. So for that we'll again dilate our thresholded image, but in this case we'll keep the width a bit less. Let's name it dilated 2 for example. So you can see the dilation is covering the words and not the entire line, because now we want to detect individual word, right? Now we'll make a copy of the original image so that we can reuse it. Now in order to detect the words in order, we'll have to first go line by line, right? And we already have a line sorted. So for line in sorted contour lines, we get the coordinates of the contours for x, comma y, comma w, cv2 dot commanding Now we'll get the ROI of each separate line. So dilated y2 y plus h, x2 x plus w. Now we'll draw contours on each word. So after getting ROI of a particular line, we'll try to get contours in that particular line of each word. So we'll use the same code that we used in drawing contours over line. In this case, we'll be drawing contours on this ROI line. So we have written here our ROI line. Then again we'll sort the contours that have been found on a particular line, but this time we'll sort from left to right, Hence we have written 0. And earlier we had considered 1 because we were sorting vertically. Now we are sorting horizontally. Hence we have considered 0. Now for word in sorted contour words, x2, y2, w, h2 equal to now we'll draw the contour into the rectangle G3, which is the original image. We have just made a copy of the original image. Here the coordinates could not be x2 and y2, it would be x plus x2 and y plus y2. This is because when we are considering a separate line, a separate ROI of a line, we are considering it as a separate image. So for example, if we remove this line as a separate image, this coordinate would become 0. But here in this, when this line is intact in this image, this point is 200, for example. But in a separate case, it would be 0. So if you want to draw a contour on the original image, we will have to consider the original coordinates, right? So 0 plus 200 would become 200. So hence we need to add the original coordinates of the image. Hence we have written x plus x2 and not just x2. And similarly, y plus y2 and not just y2. Here instead of writing x2 plus w2, we'll write x plus x2 plus w2 and y plus y2 plus h2 instead of just writing y2 plus h2. Here we'll define the color. You can use any color of your choice. And plt dot ensure img3. Here should be contours. Yep, so this is our output. You can see there are some noise that have been detected. You can get rid of those by using CVD contour area and set a specific size. So, for example, if cv2 dot contour area what is less than 600, for example, then continue. Let's see if this works or not. Yep, so it has worked. Now can reduce the size. Let's keep it 400. Now you can see all the very small contours which can be considered as noise have vanished. So you can adjust this size according to your requirement. Now we'll try to see if the words that we have captured are in order or not. So for that we'll create a words list. Here we'll write words list dot append. We'll append the coordinates of each word: x plus x2, y plus y2, x plus x2 plus w2, y plus y2 plus h2. Now we'll rerun the program. So now let's try to view this word. So 0, 1, 2, 3, 4, 5, 6, 7, 8. This is the 9th word and 8th index. So 9th word is equal to words list So from here we'll try to grab coordinates of the 9th word, which will be 8th index. And now we'll try to get its ROI. ROI 9. We'll use the original image. 9th word. The Y coordinate. Three, comma, 0, 2. So NumPy considers row first and then column, right? So hence y plus y2, y plus y2 plus h2, x plus x2, x plus x2 plus w2. Now we'll display the image plt dot ensure ROI 9. So you can see we successfully displayed the 8th index, right, which was this. So yeah, there are better deep learning methods for detecting the text, but the aim of this tutorial was just to show how you can use basic simple image processing techniques for doing line segmentation and text segmentation in order, keeping the order of the lines and words. So I hope you found this tutorial helpful. Don't forget to subscribe. Thank you very much.